All right, everybody. Today's lesson is a little bit involved just because we're going to be finding the equations of lines again. Okay, so we've done it when you were given slope and a point. Yesterday we did it when you were given 2 points. And today we're going to look at 4 kind of special cases. And they aren't so special. This is just facts that you have to know about lines. All right, the first method we're going to use is with slope. So you'll be given slope, and you'll also be given a point, but this point's going to be special. And by special, I mean it is going to be a y-intercept, or the y-intercept of the line you're looking for. All right, and that makes the problem incredibly easy. The second type of problem we'll be looking at is you'll be given a point and a line that you're parallel to, and then find that new equation for that other line. You'll be given a point and a line you're perpendicular to, and then lastly you'll find the equation of a line based on its graph. All right. So let's look at special case number 1, the easy problem. So we have find the equation of the line with a slope of 5/8. So the first thing I would do is write down given information. In this case, slope, m, is 5/8, and the y-intercept, and you may want to write that y-intercept equals -20, or you may want to write b equals -20. If you remember in slope-intercept form, this equation, or this general formula, shows us what the slope is of a line and the b value, which is the y-intercept. They're the same thing, y-intercept and b. And so they've basically, if you get a problem like this, have told us the problem or the answer. Y equals m. Well, what's m? M is 5/8. That was told to us. X plus b. Well, what's b? And you go plus, and b is -20. They told us that as well. Now, we're never going to write plus -20. The way we'd write this is just y equals 5/8, and plus a minus is the same as just subtracting -20. So this line has the characteristics that were described in the original problem. What's his slope? 5/8. What's his y-intercept? -20. And we're done as long as we can stop at slope-intercept form, which that's where I want you to stop today. Okay, that's it. Y equals mx plus b. They tell you m, they tell you b. We're good to go. So look at the second problem. Here you'll see we've got 2 lines that are parallel. Parallel just means they go on and on forever, but they're never going to intersect each other. Now I'm going to count the slope of each one of these. So I'm going to start at a point. I'm starting on line A here. I'm going to count a rise, 1, 2, so I just rose 2, and then a run. I ran 1, and that put me on another point. So this line's rise over run is 2. So let's go slope of line A. His rise was 2, and his run was 1. Rise 2, run 1. And it doesn't matter. I could have picked any points on this line. I'm going to try a different point. This time I'm going to grab a point way down here, and I'm going to count all the way up to that point. Watch what happens here. I rise 1, 2, 3, 4. So my rise was 4. And this time when I run to get to that other point, I run 1, 2. So I ran 2. So my rise in this case was rise 4, run 2. Well, that's the same as 2 over 1, both divisible by 2. So you can pick any 2 points on a line and count rise to run to get to the next point you find, and it'll always give you exactly the same slope. So that's the slope of line A, 2 over 1 or just 2. Now let's do the same thing for line B. So I'm going to start at this point. I'm just choosing the points that they marked. Notice it goes up 1, 2, so it rose 2, it runs 1. goes up 2, it runs 1. So line B has a slope of rise 2, run 1. Rise 1, 2, run 1. And this is what is true about all parallel lines. They don't all have a slope of 2, but any line that has the same slope as another line are parallel. Okay? If line A and line B are parallel, if line A has a slope of 7, then line B has to have a slope of 7. If they're parallel and line A has a slope of 5/8, line B has to have a slope of 5/8. That brings us back to our problem. Jump forward here. The second type of problem is find the equation of the line through -1/8. So they've given us a point, and they've said parallel to this line, y equals 4x minus 5. Well, how does that help us? Remember, the other day we had to have 2 points to find the equation of the line, or we had to have a slope and a point. Well, it turns out when they tell you what line you are parallel to, they're actually telling you the slope of the line. And let me show you what I mean by that. If I want to be parallel to this line, y equals 4x minus 5, I have to have the same slope as him. Well, what's his slope? His slope is 4. Remember, y equals mx plus b. The slope of this line is 4. I want to be parallel to him, so the slope of this other line has also got to be 4. And once I recognize that I have a point it goes through, and I know its slope because it has to be parallel to the other line, I can just write my point slope form. I can do my substitution, y minus y1, there's my y value, 8. My slope, which I now know because I'm being parallel, is 4x minus, careful we got double negatives here. And now it's just cleanup work. Double negative becomes plus 1. We do a little distributing. Y minus 8 equals 4x plus 4. And again, we're just going to go to slope-intercept form for all these. Y equals 4x plus 12. So that's the equation of a line that is guaranteed to be parallel to this one because they both have the same slope. And it goes through -1/8, which you can verify. If I plug in -1 for x, 4 times -1 is -4, and -4 plus 12 is 8. So I've got all the characteristics that that line was supposed to have. It goes through the correct point, and it's guaranteed to be parallel to the line y equals 4x minus 5. Third type, instead of being parallel, we're going to be perpendicular. Okay, the question, then we'll talk about of perpendicular lines. Perpendicular means they cross at a 90-degree angle, usually signified by this little square that we put in there saying that's 90 degrees. Now in this case, the slope is already kind of laid out for us, right? We could count this slope if we wanted to. Notice I could pick this point, for example, count up 1, 2, 3, and over 1, and that would get me to this point on the line. So the slope of this line is rise 3, run 1. Because they've given us the equation, though, we didn't really have to count it. I can see my slope is 3. That's the same as 3 over 1. So I know the orange line has a slope of 3. The blue line here, let's see if I can find a good point for him. Right there's a nice point. And I'm going to count to another point. Let's see here. I'm going to choose this point right down there. I'll start right there. Let's count his. He goes down 1 and back 3, or over 3, 2, 3. Down 1, run 3. That's the slope of rise was -1, run was +3, so -1 over 3. Again, they've given us the equation for the line, and you can see it is -1 over 3, or -1/3. Now, what do these slopes have in common with each other, or how are they related? This guy has a slope of 3. This line in blue, which is perpendicular to it, because it had that right angle right here, his line is negative 1/3. And here's how they're related. These two numbers are called negative reciprocals. Negative reciprocals, all they mean is, think of this 3 as a 3 over 1. All integers are over a 1 like that. Negative means they have the opposite sign. So this one was positive, so the perpendicular line is negative, the opposite sign. Okay, so that's the negative, always opposite signs, and the reciprocal means flip it over. The original line was 3 over 1, the perpendicular line is 1 over 3. So you have to flip the fraction over, and you have to change its sign. That's going to be key. Negative reciprocal. Change the sign and flip the fraction. So let's take a look at the particular lines. So this time I want a line that goes through the point. So here's my point, 4, 6. But this time I got to be perpendicular at a right angle to this line right here. So let's take a look at the problem again. I want to be perpendicular to this line. This line has a slope of 4/5. That means my line that's going to be perpendicular to it, and I always like to put M and then a little perpendicular sign, it's an upside down T, is going to be, and I changed the sign, it was positive, so now it becomes negative, and it was 4 over 5, so it becomes 5 over 4, the negative reciprocal. And then once again, just like in the previous problems that we've done, I now know a point my line goes through. I know the slope it must have to be perpendicular to this guy. And so I can pull out my point slope equation, y minus y1, m times x minus x1. Hopefully you realize now we use this a lot. I substitute y minus my y value, which is 6, equals my new slope, negative 5/4. And then x minus my x value, which is 4. We do a little bit of distributing. Get rid of that fraction. Y minus 6 equals negative 5/4 x. And that's going to give me positive 5 when I multiply negative 5/4 times negative 4. And I just have to add my 6 to both sides, and my y will be alone. So y equals negative 5/4 x plus, in this case, 11. And we are done. Last type of problem. Okay, we give you a graph, and you have to find the equation for this line. The key thing is, everybody, if you did last night's homework, is all you have to do is find 2 points. And in this case, they're marked for us. Okay, so you look at your graph, you find 2 points, and now it's just like yesterday's assignment. Step 1, find slope. And step 2, use your point slope equation, and you can write or determine the equation for that line. And that's it, everybody. Okay? So they'll give you a slope and the y-intercept, a point and a line you're parallel to, a point and a line you're perpendicular to, and then a graph. Each time you try to find the equation of the line in slope-intercept form.